Hi, my name is Dinesh and I'll be talking about chapter 2.3, which is polynomial equations. Solving a polynomial equation by factoring. X to the power of 6 minus x to the power of 4 minus 2x equals 0. So first we have to factor out the common factor, which is x, which will equal to x brackets x to the power of 5 minus x to the power of 3 minus 2 brackets equals 0. After that, we have to factor the trinomial, which is this part here, which will give us x brackets x minus 2 brackets x plus 1 equals 0. When we do that, after that we have to solve for x. So we'll get x equal to 0, or x minus 2 equals 0, or x plus 1 equals 0. And after we solve it, we'll get x equals 0, or x equals to 2, or x equals to negative 1. Finding roots of a polynomial function. Solve fx equals to x to the power of 4 minus 3x to the power of 3 minus plus 5x to the power of 2 minus 27x minus 36 equals 0 by finding real roots. Point. B represents all factors of the constant term and A represents the leading coefficient. So we do B over A. A is the leading coefficient. The possible real roots are plus minus 1, plus minus 2, plus minus 3, plus minus 4, plus minus 6, plus minus 9, plus minus 12, plus minus 18, plus minus 36, which are all real roots of 36. You type the equation into your graphing calculator to get the graph, and then you choose an point from the x-axis to solve your calculations for fx. So I chose 4, positive 4, and I did the synthetic division, and you'll get a remainder of 0, so you can see that x minus 4 is a factor. Factoring by grouping, x to the power of 3 plus x to the power of 2 plus 9x equals 0. You'll get x to the power of 2 bracket x plus 1 plus 9 bracket x plus 1 equals 0. So you can put that together, which will give you bracket x plus 1 bracket x to the power of 2 plus 9 equals 0. Then you solve for x plus 1 equals 0, x equals negative 1. So x to the power of 2 plus 9 equals 0, x to the power of 2 equals minus 9, x equals square root of 9. Square root of x equals square root of 9. So this is the non-real roots. So you get 2 real roots and 2 non-real roots, which will be negative. The real roots will be negative 1 and 4, and the non-real roots will be 3 and negative 3. Real roots are the point on the x-axis, and non-real roots are the points not touching the x-axis. Okay, now I'll be talking about chapter 2.4, which are families of polynomial functions. A family of functions is a set of functions that have the same characteristics. A family of polynomial functions will have the same degree, will have the same zeros, will cross the x-axis at the same place but different for the y-axis, will have the same basic shape, will have different local max and min. Some will be higher and some will be lower. An equation for a particular member of the polynomial function can be determined if a point in the graph is known. So this is a degree tree, starts at quadrant 2 and ends at quadrant 4. Has root at negative 2 order 1 and root at 1 order 2. So the parent function is fx equals minus brackets x plus 2 brackets x minus 1 to the power of 2. So these are the parent function is the main function, and the leading coefficient changes how the graph looks. The points on the x-axis will still be the same, but the y-axis changes. The zeros of a quadratic function are 2 and 4. Write an equation for the family of a quadratic functions with these zeros. Fx equals k bracket x minus 2 bracket x minus 4. K can be any real number, but k cannot equal to 0. Because if k equals to 0, then the whole equation is 0. Write equations for two functions that belong to this family. So you can put 3 bracket x minus 2 bracket x minus 4 or 0.5 bracket x minus 2 bracket x minus 4. So 3 basically it looks longer, and 0.5 makes it look shorter. The zeros of a quadratic function are 2 and 4. Determine an equation for the member of the family that passes through the points 1 and 2. So first you have to sub in the points 1 and 2 for x and y. So here's the equation: y equals to k bracket x minus 2 bracket x minus 4. So you sub in y 2 and the x for 1. So you get k 1 minus 2 1 minus 4, k negative brackets negative 1 times bracket minus 2. So 2 equals negative 3k and k equals negative 1.5. Therefore, the equation will be fx equals to negative 1.5 brackets x minus 2 brackets x minus 4. Write an equation for the member of the family that has a y-intercept at negative 80. So you just have to find the point negative 80 and you sub in the 2 points for x and y. So negative 80 equals k 0 bracket 0 minus 2 bracket 0 minus 4. Negative 80 equals k minus brackets minus 2 brackets minus 4. Negative 80 equals 8k, k equals negative 10. Therefore, the equation is fx equals negative 10 bracket x minus 2 bracket x minus 4. Determine an equation for the quadratic function represented by following graph. So the degree is 4, the leading coefficient is more than 0, the parent function is k, brackets x minus 4, brackets x minus 1, brackets x minus 3, brackets x minus 4. So you choose a point on the graph and then you sub in for x and y. So it will give you 2 equals k, 2 minus 0, 2 minus 1, 2 minus 3, 2 minus 4, and you will get k brackets 2 times brackets 1 times brackets negative 1 times brackets negative 2. So 2 equals 4k and k equals 2. Therefore, the equation is fx equals 2 brackets x minus 0, brackets x minus 1, brackets x minus 3, and brackets x minus 4. Okay, and now I'll pass the presentation to Anissa.